Hello everyone, this is Dr. Rajesh working as assistant professor in GMN College Ambala Kent. Today my topic of discussion is motion of projectile. So in this we will find its motion and the path described. And the problem is stated as this one. A particle of mass m is projected in a vertical plane through the point of projection with velocity u in a direction making an angle alpha with the horizontal. To find its motion and path described, so we shall be making the firstly xy plane, okay, and this is the point of projection. Say the particle is projected from here and it follows the parabolic path. It follows the parabolic path, okay, and it is projected with velocity here u, with velocity u, and making an angle alpha. Okay, fine. This is x-axis, this is y-axis. At point O we can resolve the velocity vector into component. This is along the horizontal is u cos alpha and u sin alpha. Let p xy be any point during its motion at time t, okay, and say here we draw the axis again like that, okay. This is x-axis, this is y-axis, and then this is the tangent. So this is the force, okay, and the components of force along the x-axis and y-axis is f of x and f of y. F of x will be equal to m d square x dt square, okay, and f of y is equal to m d square y dt square. This is horizontal component of force, this is vertical one. From the last lecture it is very clear that the only force acting upon the particle when it is describing the projectile motion is the force of gravity. So in this case the only force that will be acting upon the body will be force of gravity, and that will be in the downward direction, and it is a mg. So if we say what will be the equation of motion for this particular projectile, horizontal force is 0, so f of x will be 0, and one is in upward direction, other is in downward direction. So we can say that f of y is equal to mg and minus for their opposite direction. So this implies that substituting the value of m dx square dt square equal to 0, m d square y dt square is equal to minus m g. This will cancel out. This implies that here m cannot be 0. This implies that d square x by dt square is equal to 0 implies dx by dt is equal to some constant c1, okay. Using the condition at point O, at point O, this is the velocity component, horizontal part of the velocity, dx by dt, horizontal part of the velocity at point O, t is 0. Okay, fine. And horizontal part ux is dx by dt at O, which is u cos alpha. This implies that using this in equation A, we get u cos alpha is equal to c1. Thus A implies that dx by dt is equal to u cos alpha. Now integrating again, we will get u cos alpha t plus c2, where c2 is arbitrary constant. Again at point O, t is equal to 0 and x is also 0. Therefore this is 0, this is 0, this is c2. This implies that c2 is equal to 0. Using in B implies x is equal to u cos alpha t, and this is the value of x, and name it as equation number C. Now we see what will happen in case of a vertical component. Here we see d square y by dt square is equal to minus g. Integrating both sides, dv by dt is equal to minus gt plus c1. At point O, dy by dt, which is the vertical component of the velocity at point O, you can see is u sin alpha. This is u sin alpha and time is 0. Therefore this will be u sin alpha 0 plus c1, implies c1 is equal to u sin alpha. Using this in equation D, we get, using in D, we get dy by dt is equal to minus gt plus u sin alpha. Now again integrating with respect to t, minus gt square by 2 plus u sin alpha t plus c2. At point O again, at point O, t is 0, y is 0. Therefore c2 is equal to 0. Using in E, this implies that y is equal to minus g t square by 2 plus u sin alpha t. Okay, and name it as equation number F. Now from equation C and F, we have x is equal to u cos alpha t, y is equal to minus g t square by 2 u sin alpha t. This implies that from this equation t is equal to, we will eliminate from this equation and this equation t. So from this we can calculate t. It will be x by u cos alpha. So this is further equal to minus g. This will be x square u square cos square alpha. Here is 2 plus u sin alpha x by u cos alpha. U to u will cancel out. This will be minus g x square 2 u square cos square alpha plus x. This will be tan alpha. So therefore y is equal to x tan alpha minus 1 by 2 g x square u square cos square alpha. This represents equation of trajectory of the projectile. Therefore, in this lecture, we have studied the motion of the projectile and determined the equation trajectory for the projectile. So this is all I have from this lecture. If you have liked the video, please like, subscribe, share and comment. This is Dr. Rajesh saying you goodbye. Thank you for watching.